workshop. Pretty cold, wintry Tasmanian workshop actually. What I plan to do over this next few days, and I hope to condense it to one video, but if it's two, it's going to be two. What I want to do is I want to make a 12-inch or 305mm sanding disc unit. Now, I have looked at them to buy them, and you know, a decent one is between $800 and $1,000 or more. And I've seen different versions being made on the on YouTube, and there's not that many that I would consider to be safe. So what I want to do is show you my way. It may not be the right way, but my way of making a safe sanding disc that is hopefully a fairly reasonable and very usable 12-inch sanding disc. So what I'm going to use for my base unit, the choice of electric motor is very important. I've seen people use, well, what I can sort of see to be washing machine motors. They're no good. You need a sealed motor with cooling fins, such as this one, and a fan on the back. There's no windings open to collect dust or short out or electrocute you. If possible, you need the correct switching to go with the motor, that's mated with the motor, not an electrical output household on-off switch. These switches are safe, pretty well safe as you can get them. Safety in a workshop environment is very important, certainly when it comes down to electrical items. You know, you can easily get electrocuted. So, I'm going to show you the safest way I know of how to do a do-it-yourself sanding disc that you can really use. Like I say, this is my way. It may not be the right way. This is my way. So you can follow what I do, or you can just look at it for entertainment. So what we need to do is, firstly, I've already pre-slackened this nut, and this is a drive plate. Now what I was going to do, or my first thought, was to remove this, put it in my lathe, machine the cutting area away, so I'm just left with a disc, and then drill holes in it and use this as a drive plate. And I use as much of the original mechanism off the old unit as possible. This unit is 500 watts, actually it's 550 watts. So it's 0.65 of a horsepower. So it's not quite 3/4, but it's over half horsepower. Obviously you have to have a special drill to drill through this, because this is tool steel. And the price of a drill to do that job was quite expensive. So what I did, went to my local hardware store and found a diamond masonry cutting disc for an angle grinder with already holes drilled in it, and it was about 1/4 of the price for me to buy this and use this as a drive plate than what it was for me to purchase a drill to do that. So what I have to do now, because the center of this hole and the center of this hole is two different sizes, I have found a hard steel washer which exactly fits the center of this, like so, and I'll put this washer in my metal lathe and bore the inside out to the dimensions of this, so it fits into this drive coupling perfectly. So then we'll have a very robust drive plate for our 300mm, 305mm or 12-inch sand index. That's the main thing I'm after, is the motor with the switching unit. And nice tidy lump that is. Now what I also want to do is I want to retain this metal bracket unit, nice heavy double metal bracket unit here. It's already got the holes pre-drilled in it. What I'll do is I'll now cut this frame off because I don't require it, and then reverse it so I've got a nice flat area here, and put the motor in through from this side, and use this as my main mounting bracket. I think that'll work. I've had a rethink actually. Let's bring the camera up here a little bit so you can see me mush. I've had a bit of a think about this, and I think that this is, I would better explain doing this job if I actually did a series of videos. I'm not going to be able to do this in a 5-minute video and put all the information into it that you would probably require. So this is going to be video number 1, and not sure how many videos it's going to take, but I thought, well, if I'm going to do it, let's do a proper. This project we will be actually using or having the use of a metal lathe, metal work lathe, metal mill, CNC router, the wood lathe, and the table saw. So quite a lot of the machinery that I've got here. Let's make quick work of it with it. Okay, so now we've got our basic hardware parts then, shall we say. So we've got a nice mounting bracket, a nice 90-degree and very, very solid. Mount a motor in to make the chassis. We've got our motor with a switching unit already built in, which we know is matched to the motor, and everything's going to work fine. We've got quite a few of these too, these knobs with threads on, and we've got a drive plate and drive mechanism to mount up to the... Putting this motor on backwards onto this plate, there's a little flange here that I just have to cut off, and I'm just following the burrs off it now. There's another slight modification I had to make where the housing, here, where this housing goes into the back of this bracket now. I just had to take a small section out of here because it was just touching this area, so I just cut it with an angle grinder and just taking the burrs off. So now I can screw, bolt this on. Firmly. So we have clearance all the way around here now, and we have an on-off. touching. Let's try these on now to make sure adequate clearance. Okay, what we need to do now is just bore at the centre of this washer. I'd just like to mention at the moment, my lathe normally during the summer anyway is not in this sort of state, but what I do, because it gets fairly damp around here in the winter, I spray the lathe with oil, and of course all the dust just sticks to it, and the odd occasion when I have used it, I have actually cleaned it up. Because the muck builds up a little bit, but every now and again I clean it up. So what I'm doing now is I'm just using a piece of wood to be able to press this against to hold it square, and then do the chuck up and take that out. So now I know that this is fairly square. I'll just ease that up. Now then, I think you can see everything there if I take this out. Could pop the drill through that first, I think. That's what I'm going to do. Because this is such a small item, and I'm only just gripping on it, and I'm not gripping tight enough to I don't want to crush it. I'm going up a couple of drill sizes at a time. Hopefully it's not going to fly out at me. It's come loose in the jaws. Yeah, this has turned out to be quite a delicate operation. Even with this small piece of tool steel, lathe tool steel, even this is too much for that. So what I've had to do is get my very, very small boring bar, and it's nearly like making parts for a clock. But yeah, this is a very, very small piece of work and not much to grab hold of, so yes, I'm going to have to use very small tools to do it. Very small amount at a time. I don't know whether you can read that. The battery is actually going down on my calipers here, because it's pretty cold, and of course when batteries are cold they tend to lower their voltage, and this is now showing that needs replacing. But I want 14mm, but this is 14.1, which is absolutely perfect, really. I've also decided to machine this dowling area here, or ridge off, because I want the steel part of that shim that I've just made, or spacer, to come flat up against this. So I'm just going to get rid of this as well. Now this is aluminium, and there are several different types of lathe types of tools. Now generally the gold coloured type ones are for steel, and the tinned or more steel colour looking ones are for aluminiums and plastics. So that's what I've always been brought up to believe and use, and works for me. So here we go. It's actually rather difficult to be able to get the camera in here so you can have a look, and I can actually operate the lathe without getting myself in the way, but we'll have a go. And there you can see the end result, just the shoulders moved. And it's not an absolutely crucial area.